So we're starting on chapter number 4, and this is going to be part 1, and it's going to be the part 1 for tissue, actually histology. We're beginning on page 117, and we're taking a look at various tissues of the body that we'll be considering. And the big overview that you need to know is that in the overall sense, when we're considering resident growth factors and so on, is that we distinguish between 4 primary tissue types. This is not embryology. Embryology is a different science from which we're going to be able to see the flow and the differentiation of tissues, organs, and the organism itself. We'll have our chance at that. But for right now, we're just considering the 4 primary tissues, which are muscle, including cardiac, skeletal, and smooth muscle, epithelium, which is going to be the lining of things, both ectoderm, which is a part, or a reference to the skin, as well as endoderm, which is a reference to the lining of the stomach and digestive system and the respiratory system. And so whenever we have an interior lumen that's being lined, we think of epithelium, and when we have the exterior lumen, which is the space around the body that is also being, warded off by the surface tissue that is in epithelium. Finally, then we have connective tissue, which is abbreviated CT. Okay, so when you see CT, you need to think connective tissue, and that's going to be made out of cells that actually produce a matrix. A matrix is a ground substance and fibers, normally speaking, although there are some CTs in which that's not completely the case, like blood, for instance, is a connective tissue. Bone, however, is a classic connective tissue in which the cells that form the bone are the osteoblasts, and osteocytes, rather, I should say, reside in the matrix, and then there's osteoclasts, which break it down. So we'll take a look at a number of different types of connective tissue, not just bone, but also cartilage and tendons and ligaments, and so on. Then there's neural tissue, which is making up the central and the peripheral nervous system, and the associated cells that, provide anchoring and support for the central and the peripheral nervous system. Okay, and we're beginning ultimately with the epithelial tissue here. Epithelial tissue has certain features that we need to know about. They give us some bullets here, covering or lining. And I mentioned that to you before. It could be an outer lining. It could be the inner lining of something, like the stomach, the oral cavity, that sort of thing. We have glandular epithelium, which produces secretions of various kinds and hormones as well. Okay, so the role of the interface here between tissue and space is of consideration. So it's there to protect the underlying tissue. Number 2 is absorption in some cases. So if you are in the intestines, you'd like to be absorbing nutrients. If you are one of those cells, if you're in the lungs, you'd be exchanging oxygen and CO2. There's filtration, which if you're a capillary, you have to provide nutrients for all of the 50 trillion cells in the body. There's excretion, so those cells have to be able to metabolize and send the, waste products back out. Secretion, so we're actually thinking now about, the kidney has a lot of capability of secreting waste products from the body. Okay, sensory reception, so there's going to be touch and other types of mechanical reception. You know that you're near another object because it's pressing up against you. Okay, there's special characteristics. It is avascular. That's an important detail. Take a look right there. at this sort of bottom line. It is avascular. There's no capillaries. It is itself the capillary, but it is not provided with directly perfused blood. Okay, nearby, and it has to diffuse. It is innervated, so we have the ability to feel things. It's readily regenerating itself, so that's an important detail of the epithelial tissues. And here we have some shapes to consider. Let's take a look at the shapes that they're offering us. First of all, they're describing here a very flat-shaped cell, which we'll learn soon is this one right here, is the squamous cell. And what they're trying to do here for us is they're distinguishing between one layer of cells, so we refer to that as a simple epithelium, and then a stratified situation where we have a number of cells. If we look at the very top cell, we can see that it is it's at the apical surface, of course, and we can see that it's flat and has the characteristic shape of a squamous cell. And so we're going to be calling this stratified squamous epithelium. Down here, the cells might have a more round appearance and might not have this characteristic appearance, so we'll be looking at the apical surface to make the determination. In addition to that, either of these tissues has a basement membrane upon which the cells are bound to and supported by the basement membrane. Okay, the basement membrane can go through changes depending on the conditions around it. We'll be looking at that when we consider nutrition, for instance. Okay, so then we have three general shapes to consider. We have the flat little sort of like a little tile that we can, if you're tiling your floor or putting flagstones down, we have that shape to it. If you look from the edge, you just see sort of a spindle-looking thing. If you look from above, you see the flat tile. Here's something that's called cuboidal. So actually it's sort of spherical when you look at the real thing. Here the nucleus is elongated and flat. Here the nucleus is round and surrounded by equal amounts of cytoplasm. And then we have something called the columnar. This is you can imagine that if we have a bunch of these together, we have a very substantial tissue, quite thick, quite substantial. And notice that we have cytoplasm in excess on one side up here. So these stand tall in that regard. Usually the nucleus is also elongated in the direction of the tallness. Okay, so three different things going on there: squamous, cuboidal, and columnar. Okay, then they give us this example right here where we have a simple squamous and we're in the lungs and we're considering gas exchange. When you get used to looking at micrographs, you can pick things out pretty easily. This is the type 1 alveolar cell. This is the actual squamous cell. There's air in here. What you're not able to pick out right away is that this is also a squamous cell, but it's part of a capillary, and there should be blood passing through here. Okay, so the blood is in, balance with the air, and we're getting the CO2 coming out of the blood. We're getting oxygen going into the blood, and that's how that works. This is also characteristic of what I would like to call endothelium and the endothelial matrix, and it's wherever we have capillaries, we also have simple squamous epithelium. In fact, wherever blood goes, here's a little capillary right there, as I mentioned. Wherever blood goes, it's seeing, or red blood cells, wherever red blood cells go, they're seeing simple squamous epithelium. And we give that particular simple squamous epithelium the name endothelium. And then the matrix that is around that capillary is called the endothelial matrix. And it really matters because we have an interesting American diet that actually causes pathology in that matrix. Okay, and it has a lot to do with the changes that occur with type 1 and type 2 diabetic issues and the inflammatory nature of some of our food, and the chronic disease that occurs when we have an imbalance of certain nutrients. Okay, so we'll take a look at that.